This video is brought to you by Heatcraft Refrigeration.
This morning we have a evaporator and condenser we're going to be changing. So we're going out with some old Heatcraft equipment and we're coming in with some new updated Heatcraft equipment. So it's pretty much a like-for-like swap, so it shouldn't be a big deal. Everything's right down in here, so we're working on getting the equipment on the roof pumped down right now so we can start unhooking everything. Our equipment's over here, so all that we're doing is pumping down all the refrigerant into the liquid line receiver. We're going to shove the gauges in the unit and then we'll recover the gas down on the ground. It makes it a lot easier. So basically we're just going to unhook this. Our crane will be here in about 45 minutes. And we still need to get in there to do the control voltage. All right, so we've got it pumped down. We've got power shut off. It's time to disconnect. We're just gonna mark everything and move along. But you can see this thing's just all rusted out. This equipment's in bad shape. So customer, this is a preventative change. It was just, we've done a lot of work and they wanted to update it. So that's the only reason why we're changing it.
So while we're waiting for this equipment to be lifted on and lifted off of the roof, let's talk about this. This equipment, like I mentioned in the beginning, is being replaced because it's a preventative thing, right? This equipment is 10 years old. It's from 2014, and the customer abuses this equipment. They've beat it down. And so they had some issues with it, and they know that this particular equipment has a lot of use. Basically, they're in and out of this box just like it's a reach-in cooler. So they wanted to go ahead and opt for new equipment, new refrigerant. We changed it. It's fully AWEF compliant because we used a matching condensing unit and evaporator. And we changed it over to 448A, which makes it compliant with the state of California code regulations. So we are all good.
All right, our new unit is set. We're just gonna hook up the lines, kind of move stuff around. We're getting ready to pull the evaporator downstairs. This is an Intelligen unit, so we're not gonna need all the wires going back downstairs because it's just powered from 208 volts and that's it. So we'll start by taking all the panels off, getting it all ready to make it easier, that way we're not fighting anything, get it positioned, and then we'll deal with the lines and all that stuff. This is pretty much a like-for-like swap from Heatcraft to Heatcraft, so everything really lines up. So we're just fixing some electrical, and then we're going to hang the coil using the same coil bolts. All right, we got the new coil hung. We had pre-done some electrical work to make it a little bit easier, so now I just got to run conduit to the knockout, and then we got to pipe in my coil right there. So should be pretty good. We're moving along. All right, we got our electrical done, ran into the coil, already hooked up. We still got to do the drain line. We're working on that. And we've got the piping pre-done. We're going to slide insulation on it and stuff. So I got to braze a few joints, then slide some insulation on, go from there. It's really important when you're working on these things that you deburr everything, you braze with nitrogen, because this has EEVs in it and you want to be 100% sure. Look at that drain too. A bunch of sludge in there. That's nice. All right, I took some of the heat blocking compound, the Viper wet rag. It's protecting the inside right there, the inside where the 3/8 goes in. We're going to do everything but that top braze joint right there on the suction line because we're going to slide the insulation down and over the P-trap.
That trap's way crooked.
It's okay.
Okay.
you hold that ladder?
No. That should be fine here. All right, we're all piped in. The insulation is slid over. Liquid line up top. We just got to do the drain line now and finish up on the roof. All right, and these guys over here are brazing or just getting done with the brazing up here. We're all connected. We're done with the electrical up here. Disconnect mounted. We just got to fasten up the conduit and stuff. Now this one had defrost clock and stuff in it, but we took all that stuff out because it's Intelligen controlled. So no time delays, none of that. Just pure contactor essentially and pressure control. All right, so I've got the web server card right here, or multi-system card really, because this has the wireless connectivity to my tablet. So we're just gonna plug it in right there, put the screws in the bottom, and then we can set it up and the customer will be free to have their IT department hook up internet connection to it. All right, we are ready to turn power on. We got the web server card installed over here. We got the transformer back behind here tapped. We got the drain line heater hooked up. Main power, drain line heaters ran over. We're gonna insulate it right now. So we're ready to finish the evacuation and charge it. All right, we got the vacuum pump running, so we're looking pretty good. We're ready. Basically, as soon as the evacuation's done, we're ready to turn power on. The problem is, on these guys, on the really cool thing about the Intelligen evaporators is that the EEV, the electronic expansion valve, they come in the mid-seated position. They're open. So we could flow nitrogen, we could evacuate. Once you turn on power, it closes, and then you have to wait for it to call for cooling for it to open again. So keep that in mind when you're working on these things. Don't energize until you're done doing your vacuum. All right, we just powered the unit back on, and the solenoid valve, or the EEV, closed. So now they're gonna start adding refrigerant into the high side, putting as much as we can, then I'll get it to turn on once I get it all set up. All right, these guys are super easy to set up. So I just basically entered the expert password, said set up from the evaporator. We're gonna continue. We'll just call it a freezer, that's fine. It's not a freezer though, it's a wing freezer. All right, condensing unit wired, no. United States, set the time zone. I should have gone the other way. Pacific Standard, daylight savings, no. Today is 2024, October. I always get mixed up on whether or not it's daylight savings time or not. All I know is we change in the fall and the spring. October 2nd. It's warm in here. We need to get this box running. So these Intelligens are super easy to set up. October 2nd, and it is 11:10 a.m. 11:10 a.m. We're good. Refrigerant is 448A. We're good. Corel EXV. Defrost. Low temp, medium temp electric. That's what we got. We're gonna go timed for now. Box temp set point. We need to get that from the manager, but I think it's 27, I think is what they want. Start system. So we got to get a minute, it's in a delay, and then it'll open up the EEV, and they're starting to get ready to charge it on the roof. All right, the EEV just opened up, so now they're gonna be charging it on the roof. They're gonna go clear the sight glass, but the system takes 14 pounds of total refrigerant in it, so they're gonna go ahead and charge it up. We're gonna let this run, and then I'm gonna work on getting connected to the tablet so we can look at the settings on the tablet. All right, with the multi-system card, you just connect it, you connect to the Wi-Fi. The default password is all 9s. Once you get in connected to the Wi-Fi from the web server card, or multi-system card in actuality, then you use your IP address 172.16.0.1, and then now we are connected to the system, all right here. System temperature set point 27, and basically it's running. So you can see what our superheat is, coil temps, all that good stuff. So I really like the ability to connect wirelessly. And once the customer gets it hooked up to a router, we can have remote access via the internet, which is really awesome. This thing's about to satisfy. It's been running for a bit. You gotta admit, it is cool being able to have connectivity using your tablet, your iPad, whatever. Changing set points, parameters, all that good stuff. It's really awesome. I dig this, and definitely think that the Multistem Card is something you should definitely pick up. Even if your customers don't want to hook it up to the internet, just being able to remotely see what's going on, see errors, all that good stuff. You can see how many defrost cycles, what motion it's in. Is it in cooling mode? If you have door sensors wired in, product load timers wired in, like you see all that stuff. So it's really nice. Again, temperature set points. You can enter service mode. You can force defrost. Go through parameters. Look at all the system history. What's the EXV step position? There we go. You can see how it's performing, what's going on. Like, so much great information. Board voltage. Really cool. Another really important thing too is up in the side over here is a transformer. You have to make sure you tap it right. This is a 208 volt system, so they come tapped for 240. So I tapped it so that way we can do what we need to do. But yeah, perfect. All right, well, we're just waiting for it to come down to temp. So the unit's satisfied, and I put it into a defrost. You always want to test defrost, make sure that all the heaters are working. So I'm up here just testing the heaters, making sure they're good, but defrost is working, pump down's working. We're looking really good. So while it's in defrost, we're just kind of monitoring the settings. We have it set to terminate defrost at 60 degrees or 20 minutes. So we changed this one. I did verify all the heaters are working. It does smell a little burny in here, but it's just basically all the oils burning off the heat strips basically. So we're just watching it, and it's literally about to terminate at 60 degree coil temp. It's nowhere gonna meet the 20-minute time. So it says 73 degrees, but that's not the temp in here. That's just because the warm heat is rising up to that sensor right there, is all that it is. So, but the coil temp is not anywhere near there. So we'll give it another second. It should be terminating any minute now. We're at 58 degrees. All right, we just turned the equipment off real quick to do some finalizing of the electrical on the roof. So now we're just waiting for it to come back on one last time. It's just going through its delay right now. And then we're gonna be all finished up. Box has been satisfied already once before. We've watched it go through defrost. Everything's good. We'll still come back in about a day or so just to follow up, because I set the defrost for 20 minutes. They're only maintaining 27 degrees in this box, so it's kind of a hybrid freezer. So we want to make sure that's not too long of a defrost. Came back out the next morning just to follow up. Box temp is good. Everything's looking good. We're going to jump on the roof, mark the refrigerant, check the condensing unit out, just a follow-up visit. Everything's good up here. Line set looks fine. Put a couple stickers on there marking 448A. Mark the liquid level in the receiver. That's the pump down liquid level. Customer's happy with the box temp. All is well, so I'm going to bill out on this one. We are good to go.
Clarify a few things. You know, when I watch these videos, I don't go in these videos with a plan. Like when I'm filming an install, you know, I don't have everything like all planned out and scripted, right? You're just hearing the ramblings of my brain as I'm going through. So as I'm editing the video, I can see like, oh yeah, I should have said that, or I should have talked about that, you know, that kind of stuff. One of the questions that I get a lot of the times is people not understanding that there is specific energy requirements when it is concerning walk-in refrigeration equipment. It's based on the square footage of the space that's being cooled, but you have energy requirements. Department of Energy basically regulates and wants you to follow a certain criteria, making sure that your refrigeration equipment is conserving energy, right? There's an AWEF rating that they give the equipment. And basically, you got to make sure your equipment's matched correctly, sized correctly, and it's very similar to the rules and regulations that we have for the air conditioning side. And surprisingly, it took this long for it to hit the refrigeration side. It's really not a bad idea that they're doing this stuff, but to some people, it kind of frustrates them because the old ways of doing things, just changing out a condensing unit and moving on, is a little bit different, because pretty much every modern condensing unit you're going to go buy today is going to be AWEF compliant. Well, what does AWEF compliant do? It's annual walk-in efficiency factor, I think is what AWEF stands for. Department of Energy regulations. Clearly, you know, a lot of the times here in California, we get these regulations before the rest of the country, but the AWEF standards, they are nationwide, I think, at this point. But basically, it just makes sure that the manufacturer is conserving energy. They don't necessarily tell the manufacturer that you have to use this or you have to do that. They just say, we want you to meet these efficiency requirements. And then they typically give the manufacturer the power to do that. So that's why you notice some manufacturers will do 2-speed evaporator fan motors. Some manufacturers will put in microchannel condensers on the roof, get a little more efficiency that way. They went with scroll compressors. They float the head pressure lower. So in the wintertime, we oftentimes would use a head pressure control valve, just like they use on this one, and it would start to bypass and flood the condenser at about 180 PSI. Well, they floated that pressure way down to the point that the head pressure control valve, for the most part, doesn't even open half the time, because they make sure that you size your equipment correctly, right? And not just the equipment, the components. So it's very important. Now, this being an Intelligen system, it has an EEV. They're getting super efficient operation, just the fact that they're using an EEV, but then they're using a microchannel condenser on the roof. But when it comes to thermostatically controlled expansion valves, that's when you really need to start paying attention, because if you know, or if you don't know, when you size an expansion valve, you size it off of liquid pressure, liquid temperature, right? And other things, right? The pressure differential across the coil, you're going to take the tonnage into factor, right? But when you float the head pressure down, when we're lowering the head pressure on the system during the wintertime operation, that's going to change the way that the valve can potentially react. If you sized your valve for 180 PSI liquid pressure, well, with the new AWEF compliant equipment, it's not very often that you're going to see 180 PSI head pressure control valves. In fact, you're probably not going to see it on most manufacturers at all. They tend to float it way down. I think it might be 100 and 125 PSI or somewhere in there. I don't remember the exact numbers, but it's all about conserving energy. If you think about it, we're artificially, the old ways, right, using a head pressure control valve, starting to flood the condenser at 180 PSI. So basically, as it gets cool outside, your head pressure starts to go down. But as it starts to go down, the old mentality was you had a thermostatic expansion valve sized for 180 PSI. So we need to make sure we maintain that head pressure. So we'd artificially increase the head pressure to make the valve operate properly. Well, now we have modern expansion valves that we can put a balance port valve in here. We can make sure that it's sized appropriately, so that way you're looking at the lowest possible head pressure during the winter and the highest possible head pressure during the summer, and you're making sure that your valve will meter the refrigerant correctly between those 2 points right there, right? And you want to get for the best operation you can. So when we're dealing with the AWEF equipment, or I mean the Heatcraft equipment, it's already completely AWEF compliant, right? I've already said that, but they have EEVs, so we don't have to bother with changing or sizing the EEVs, right? Or sizing the TXV or putting a liquid line solenoid valve on there, because on the Heatcraft equipment, the type of EEVs that they use, they actually operate as a solenoid valve too. So that valve shuts down completely, stops the flow of refrigerant. Now, of course, when you have new technology, and EEVs are not new technology, right? But they're new to the light commercial sector of the industry. They've definitely been in the supermarket side and the industrial air conditioning side for many, many years. But we're starting to see them more and more in the light commercial stuff, the smaller stuff, the restaurant stuff, right? So it's important to understand the operation and how they work, right? So you have temperature sensors, you have pressure transducers. And speaking of pressure transducers, a really important thing, many, many years ago, I had a video where I was pressure testing a system. It was the precursor to Intelligen. It was actually a QRC, which is the quick response controller, the previous version or previous iteration of this, right? And I overpressurized the system. There was special stickers on the system that says, don't pressurize higher than this. I didn't pay attention to the installation instructions. I overpressurized it. I ruined a pressure transducer, and it caused the system to have really, really low superheat, and it was flooding back because when I overpressurized the pressure transducer, I ruined it, and it thought that the pressure was different than it really was in the system. So think about it. What do we need to check superheat on a system? We need to know the saturated temperature of the refrigerant. We need to know the suction line temperature. So we use a thermistor to check the suction line temperature on the Intelligen system. and we use a pressure transducer on the low side superheat port. What we would normally use to check superheat in the system, we now have a pressure transducer right there. So we use that pressure transducer, and then inside the Intelligen board, it's doing the calculations real time and adjusting the superheat to maintain our set point. I think on this system, I think the superheat was set for like 6 or 8 degrees, and it has a really tight control of that superheat, unlike a thermostatic expansion valve, which we've all used for years and we've learned to deal with. But remember, on a thermostatic expansion valve, when you make an adjustment, you got to wait a while, got to make sure it stabilizes out, you got to make sure the box is down to temp. On this system, it's using the pressure transducers and the temperature sensors, and it's automatically opening and closing the expansion valve. But you're also not getting like a whoosh open wide, whoosh shut down. It's not going to hunt like that. If it's operating properly, it's going to be it's a step valve, right? It's barely opening up just a step, a step, a step, a step, just a little bit. So you're not going to be the big superheat swings where it goes really low superheat, then really high superheat. You're not going to see that on these systems. Now, the reason why I brought that up is because you have to understand the operation. If I had to say, the most important thing to check on these systems is, first off, make sure you're not overpressurizing the pressure transducer when you're doing a nitrogen test, okay? Make sure you follow their instructions. Next thing, make sure that you have your temperature sensors inserted into the right places, because there's specific places for the suction temperature sensor, for the evaporator temperature sensor, and for the air temperature sensor on this system. So they're monitoring all 3 of those factors, and they use the evaporator temperature sensor for defrost, they use the suction temperature sensor for superheat, and then air, obviously, for the box temperature. Understanding all of that stuff, you got to use some common sense too. There's a little well for the suction temperature sensor to slide into. It holds it against the suction line. You got to make sure you move that when you're brazing, okay? Because it does come in the little well. You got to pull it out, move the suction thermistor basically to the side. That's why I had the heat blocking compound on the suction line when I was brazing it, but I also pulled out the suction temperature sensor. So just remember, read the installation instructions, okay? Another thing that I was thinking about as I was going through this is I was talking about the Multistem Card. The Multistem Card on this, you plug it into there, and it uses a Wi-Fi direct connection. It's just like Bluetooth, but it's not Bluetooth. It uses Wi-Fi direct, and you're connecting via Wi-Fi, but the important thing to understand is it's not connected to the internet just that way. The customer has to give the system access to the internet via routers and wireless networks, of which that is for their IT department to do, because these customers are very strict about what they want connected to their networks, because they're just very, very worried about data breaches and stuff. So that's something that I let their IT department handle. I give them the location, say, here's the Multistem Card. You guys can connect via that way. And we let them make the kind of decisions on what they want to do with that. But for us in the field, one of the really cool things to know is that if you do a lot of work on the Intelligen stuff, you can actually just buy a Multistem Card and you can pull it off of this when you're done. You don't even, just because I set it up and I was adjusting settings, you can actually pull that Multistem Card off, and you can keep one for yourself. So that way, if you ever want to look at the parameters, not that it's difficult to do it from the Intelligen display, the human interface up top, but it's really awesome. If you have a really, really cold box, you just plug in that Multistem Card, connect Wi-Fi direct on your tablet. You can step out of the box most of the time and make all your adjustments, check the parameters, look at the alarms. So I highly suggest, even if your customers don't want to connect the systems to their network, if you can sell a Multistem Card and leave it on site, that's a great thing. If not, maybe your company invests in the Multistem Card and you just pull it off, store it carefully, and then you take it with you to the next job. So that way you can diagnose and look at parameters and not have to be standing in there with the fans blowing in your face. Just cool little factoids that I have, That's what we actually have, a Multistem Card that we keep that floats around. If someone's going to go work on an Intelligen system, boom, take the Multistem Card. That way you can connect it to your phone, your tablet, whatever it may be, and you can make your adjustments if that's what you want to do. Now, once you connect this to a network, you have possibilities because you can have alerts sent out. You can, you could do all kinds of stuff. You can program it basically to say, hey, when the temperature gets this high, if someone leaves the door open for this long, like, there's all kinds of things that you can do with this. So the sky's the limit. I highly encourage, at a minimum, you guys pick up one of those multi-system cards just to have it for troubleshooting reasons, because it's really awesome, again, to not have the fan blown in your face. Another thing I want to cover about this is, maybe you caught it, maybe you didn't, the clearance, okay? This customer was very specific about the location of this equipment. They did not want it moved. They understood that they were basically they were almost too close to the walls on the side of the box. And, they were 100% aware. They signed off on it. But you have to remember that if a customer's signing off on that kind of stuff, that can mess with warranties and different things too, because the manufacturer is not necessarily going to pay for you guys to spend an extra 3 hours because the equipment's installed in a really tight location that makes it difficult to service. You understand what I'm saying? So, you need to make sure that you're discussing that kind of information with your customer and they're totally aware of what it is. Now, this customer, they're specific about where they want the evaporator installed. And so that's what we did. We put it back in there. It is a little bit tight getting in there, but it is functional. You can work on it. One of the really cool things about the Heatcraft equipment is most people don't realize, even if it's not an Intelligen, man, the circuit board, there's 2 screws on the side of it that it'll kind of pull down and out of the way. If you ever need to access the EV, you can actually access it from the front. You just got to move some stuff and kind of unplug some wires and move it down. Same thing with the electrical connections over in the right-hand side. 2 screws and that whole electrical circuit board over there pops out, lays down, and then you can access behind where the transformer's at and all that good stuff. So it's really important that you obviously pay attention to your surroundings, pay attention to the install, communicate with the customer, let them know what's going to happen, and do your best to follow best practices when you're installing this equipment. I cannot stress enough the importance of brazing with nitrogen when you are working with systems that have EEVs, okay? Because the ports inside those things, the last thing you want, those are really expensive EEVs. You do not want, carbon flakes and all that stuff getting built up inside of there, just causing problems. Make sure that you're brazing with nitrogen, and purging the system before, all that good stuff, okay? I'm sure there's going to be a lot more questions. Post them down in the comments. I'll try to get to them if I can. If I miss your questions, feel free to shoot me an email, hvacrvideos@gmail.com. I really do appreciate y'all making it to the end of this video. If you haven't already, please consider supporting the channel. A couple different ways to do so. The easiest way to support this channel is literally just watch the videos from beginning to end. That really is the easiest way. You can also support it via PayPal, Patreon, YouTube channel memberships. Those are all ways that you can choose to donate to the channel. There's links in the show notes. You can also go to my website, hvacrvideos.com, where we have hats available. Little spoiler alert, we're completely out of hats right now and beanies, but we're about to do a restock. We just got them in. We're counting inventory. So this is your little notice that you should definitely see those in stock probably by the time this video posts. They will be available on my website, hvacrvideos.com. Okay. Last but not least, you see me using any cool tools, you're looking for any new tools, go to truetechtools.com. Check out what they have. If you like what they have, I have an affiliate code set up with them. Big picture, one word. If you use my affiliate code at checkout, you get an 8% discount on majority of the items on their website. Then I get a small commission. It's just another great way to help support the channel. Okay. Thank you so very much. I really appreciate you, and we will catch you on the next one.